Hi, in this video, we're going to talk through two very large numbers, the Google, which you see in the screen in front of you, 10 to the power of 100, and his big brother, the Googolplex, which is 10 to the power of a Google. And as this is to do with powers of 10, let's start off with 10 to the power of 1. Let's get a picture for what that means. So I'm going to try to convey what this number would look like, even though that will be impossible, as you'll see. But we start off with something simple that we can actually picture. And let's just use pictures stickmen. Okay, so 10 people is represented by this number, 10 to the power of 1, which is just 10. I think we can all comprehend this number. Can we stretch our imagination a bit further and imagine this number, 10 to the power of 2, 10 squared, or 100? Can we imagine this? Well, it's going to be 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yes, we can imagine that. Quite straightforward. Can we imagine 10 to the power of 3, 1,000 people? So let's see. So that's 1, 2, 3, 4, 5, 6, 7, 8, 900, and 1,000 people. Yes, we can imagine that as well. Okay. Can we imagine 10 to the power of 4 or 10,000 people? Let's see. So we've got 1,000 people, 2, 3, 4, 5, 6, 7, 8, 9,000, 10,000 people. That's quite manageable. Let's push it further and let's go for 10 to the power of 5 or 100,000 people. So 10 to the power of 5. Here we have 10,000, 20, 30, 40, 50, 60, 70, 80, 90, 1,000 people. Well, that's getting quite populated. Can we go for the million? Let's see. So we've got 100,000 people here. 2, 3, 4, 5, 6, 7, 8, 900,000 and 1 million. And already we can see that we can't really make out the people. They appear to be just tiny pixels on the screen. What about 10 to the power of 7? Well, that's 10 million. And a 4K resolution only has around about 8 million pixels. So we don't actually have enough pixels to even represent this number, 10 to the power of 7. Okay, we don't even have enough pixels. What about 10 to the power of 8? Let's just use our imagination now. 10 to the power of 8. So we're not anywhere near 10 to the power of 100, just 10 to the power of 8. 9, 10. And now let's imagine 10 to the power of 100. And if you can't, that's okay. Okay, so this is the full decimal form. It's a 1 with 100 zeros. And let's just go back to this. A 1 with 1 zero, that's 10 people. We can imagine that. A 1 with 2 zeros, 100 people. We can imagine that. Okay. 2 zeros is represented by this. 100 zeros, it's okay if we can't imagine it because it actually turns out that this number is larger than the number of atoms in the observable universe. 100 zeros, 10 to the 100 or a Google. And now let's go for the big brother. Let's look at 10 to the 10 to the 100 or 10 to the power of a Google, the Googolplex. And again, let's simplify matters. Let's start with not 10 to the 10 to the 100, but 10 to the 10 to the 1. Okay, so that's just 10 to the 10. And that's just a 1 with 10 zeros. Okay, we can represent that in decimal form, a 1 with 10 zeros. What about 10 to the 10 to the 2 or 10 to the 100? Well, that's just a Google. We can represent that with a 1 with 100 zeros. Okay. Obviously, we can no longer represent the number of people, can get a true picture of how large this number is, but we can certainly write it out in decimal form. And what about 10 to the 10 to the 3? Okay, so that's a 1 with 1,000 zeros. So that's 100, 2, 3, 4, 5, 6, 7, 8, 9, 1,000 zeros. So that's 10 to the power of 1,000. So this number is bigger than a Google, of course. 10 to the 10 to the 4. Let's have a look at what that would look like in its full decimal form. So that's 1,000 zeros, 2, 3, 4, 5, 6, 7, 8, 9, 10,000 zeros. So that's just 10 to the 10 to the 4. A 1 with 10,000 zeros. Let's look at 10 to the 10 to the 5. That's with 100,000 zeros. 10 to the 10 to the 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Now let's just jump straight to the Googolplex. 10 to the 10 to the 100. 10 to the power of a Google. And what's the full decimal form? Well, I've started writing a few. Then I remembered that it's actually impossible because, as Carl Sagan said, there is not enough space in the observable universe to write the full decimal form of this number. And to the power of a Google or a Googolplex. Thank you very much. I hope you enjoyed the video.